Use transformations to graph f of x is equal to the natural log x minus 2 and determine the domain, the range, and the vertical asymptote. Well, most of your logarithmic functions are going to come in really close to the y-axis and then do that. And this point right here is 1, 0 most of the time. Now, this will be like the graph for the natural log of x. If we wanted to graph the natural log of x minus 2, we need to remember that this is what I call an h-value. And h-values have a tendency to move your graphs sideways. And it's always opposite of what you see. So it'd take that graph, and instead of it going through where it did at 1, 0, it would shift it over to here at 3, 0. And instead of it being nice and close to the y-axis, your graph is going to be nice and close to that line right there, which is x is equal to a 2. So your graph is going to be hugging here, and then it goes through. So the 2 has caused a horizontal shift opposite of what you see. I believe it is letter A. The domain is as you scan across the x-axis, what are you using? Well, you're not using anything from this asymptote back, and you will not use the asymptote. So your domain is going to be parentheses, not closed, but open, 2 to infinity. That is your domain. There is your graph. The range on logarithms is anything, because it comes from the bottom and goes. Now it goes that way in a hurry, but it is still climbing. Your range is everything. And this one had a vertical asymptote of x is equal to 2. Use properties of logs to expand each log. Simplify as much as you can. So we have a nice fraction. We have the log base 9 of the top, the numerator, minus the log base 9 of the bottom, the denominator. Here I think they're testing to see if you remember to simplify the log base 9 of 9 to make that into a 1. And that is as simple as you go.